Usable energy is stored in chemical bonds. Chemical reactions are the rearrangement of atoms, forming or breaking chemical bonds. When atoms fall together to form a bond, energy is released. It then takes energy to break the bond, to separate the atoms. So here we can see a bond is formed, and here a bond is broken. Reminder: a covalent bond forms when atoms share electrons in order to have a stable number of electrons. A covalent bond that yields a more stable system will form spontaneously. Covalent bonds can be very strong. It can require a large amount of energy to break them. In fact, the energy needed to break the bond is equal to the energy that was released in forming the bond. Just like the energy needed to carry the rock back to the top of the cliff is equal to the energy released when it fell down. Chemical reactions can go in both directions. Products can be reactants, but they tend to be spontaneous in one direction and non-spontaneous in the other direction. Here, the spontaneous reaction would be a hydrogen atom plus a hydrogen atom becomes a hydrogen molecule. Here's the non-spontaneous direction, where a hydrogen molecule becomes two separate hydrogen atoms. The energy released in the formation of the bond equals the energy that must be added back to separate the hydrogen atoms. Two separate hydrogen atoms are an unstable system. Once they get close to one another, they will spontaneously form a molecule of H2, releasing energy. Apart, they are unstable, and it's just a matter of time until they come together, form a molecule, and release energy. Just like it's just a matter of time before the rock falls off the cliff. Systems tend to become more stable over time. When two hydrogen atoms combine into one hydrogen molecule, the reaction is spontaneous. Note that H plus H is the same as 2H. That means that it happens by itself. There's no need to add a noticeable amount of energy. The random movement of these molecules at room temperature is enough activation energy for the process to occur. In fact, this reaction releases energy. That's because the hydrogen atoms are more stable when joined together into an H2 molecule than when they are separated. You can think of the H atoms falling together to form H2. H2 is more stable than H. In spontaneous reactions, the products are more stable than the reactants. Breaking apart H2 requires that the same amount of energy released during its formation be put back into the hydrogen molecule, like pulling a rock back to the top of a cliff. In the case of the rock falling off the cliff, the potential energy converts into kinetic energy and then heat. The same thing happens when H2 is formed. At the microscopic level, kinetic energy is observed as being thermal energy. Heat is released.